If you're connected to the internet, one of the things that you're susceptible to is a denial of service attack. That's when somebody is trying to overload a particular service that you're offering on the internet so that that service is not available for anybody. And in that case, it brings you down completely. Nobody can access that service from inside or outside of the network. Sometimes the bad guys are taking advantage of a known vulnerability in a piece of software. You can send a particular packet into a device, and that packet causes that device to fail. And that causes, of course, the network to go down. You want to be sure that all of your systems, all of your infrastructure equipment, and your applications are kept at the latest versions. This will cause your network, your device, whatever's under attack to be completely unavailable. Sometimes we'll see competitors use this. They'll bring down their competitive websites, and then they're the only ones available for people to gain access to. When you deal with traffic across the internet, this is always a concern. Sometimes people are trying to get around or get through to perform some other type of exploit. Maybe they want to create a DNS type exploit so that they are spoofing DNS traffic. What they'll do is perform a denial of service to your real DNS, and then they'll be the ones that send the requests out to anybody else. So everyone is getting a DNS reply, but they're not getting the DNS reply from your DNS server. Your DNS server is under attack. The bad guys are sending their information using their evil DNS server. This doesn't have to be a very complicated process either. One very easy denial of service attack: somebody can go onto the side of your building and shut the power off. And if they turning off the power, then you are definitely out of commission. That is one of the easiest denial of service attacks. That's why if you look at data centers, everything is protected. There's guards. All of your power and switches are behind walls. Nobody can access anything in that data center. That's to make sure that you don't become susceptible to any of these types of denial of service attacks. The bad guys know that it's very easy for someone to block a single system out on the internet that's trying to bring you down with denial of service. That's why they've created a distributed denial of service functionality. They're going to have many different systems on the internet all working together to try to bring you down. And then it becomes a lot more difficult to filter that out because it's not a single IP address. It's probably not even a single IP subnet. It's stations and systems from all over the world that are now using all of the bandwidth available to bring down your particular systems. The bad guys use botnets to accomplish this. They don't go to individual machines and tell everybody manually to start their engines. They simply send out command and control out to machines that they've now already taken advantage of. And those systems are sitting there just waiting for them to have that happen. So they'll send out the message to them, and suddenly your particular server is being inundated with requests from all over the world. There can be millions of devices involved in these botnets. The Core Flood botnet, which was taken down in April of 2011, had 2.3 million devices as part of the botnet. And for these very successful, I guess you could call them botnets, they have millions and millions and millions of devices as part of this army that they use. They simply click a button and the threat comes from everywhere. Obviously, that becomes a problem for you. It's ironic, of course, because that end station that's sending those packets off to you probably have fewer resources than you do. But because the attack is distributed, they're now combining all of their power against your single system. One of the very first distributed denial of service attacks was called the Smurf attack. This goes way back. It's hard to even find a network or a series of systems that's even susceptible to this any longer, but it was a good description of how denial of service attacks could really disrupt the network. This was a relatively simple distributed denial of service attack because it used something that everybody had available, the ping command. It used a little bit of packet crafting. Let's say you're on the network, you're 192.168.1.22, and let's say you craft a ping request. You're going to spoof this request and you're going to send it out to everybody, but instead of sending it from your IP address 192.168.1.22, we're going to pretend that we're sending it from 192.168.1.1. So when we send this out, that's the source IP address for this ping. Notice that we're not sending it to a particular workstation. We're sending it to 192.168.1.255. We're sending it to the broadcast address. And back before this was a known problem, every station that received a broadcast would receive it and act on it. So as soon as they saw this ping request coming from what they thought was 192.168.1.1, they simply said, "Oh, I'll be glad to reply to that. Let me send a ping back to 1.1." Well, I'll send a ping as well. Everybody on the subnet will send a ping back to 192.168.1.1. So you could send one packet and you would have hundreds of packets potentially going back to a single host. And you could blast out all of those ping requests, and suddenly hundreds and hundreds and thousands of packets were now filling up all of the bandwidth, creating that denial of service situation.